Okay, it says it's recording. All right, so we're going to review for the Chapter 4 test today. And make sure and let me know if you can't hear me or whatever. I'll turn my sound up. And I think I know what a lot of folks' problem is with the getting into the Meet is you're signed into another Google account. Since I'm here watching it, I can hit OK. But in general, if you have trouble getting in, it's probably because you're signed into the wrong account. All right, so I need to change the presenting to be the whole screen so you can see the calculator if I use that. Okay, and we'll get started here. So number one is what you see here. Rewrite 1400 degrees in radians as a multiple of pi. See how the camera looks? A little high. Okay, so 1400 degrees in radians as a multiple of pi is our task. We're going to use that conversion factor when we go from radians to degrees, or so from degrees to radians. And that's going to be pi over 180. So that's 1400 pi over 180. I think that's another one of those people logged into the wrong account. Yep. So 1400 pi over 180. There's a quick way to reduce fractions. Just put the fraction part into your calculator and hit math, enter, enter. It's 35 pi over 2. And that looks like D, none of these. Let me double check if that's right. Hit the wrong button on the calculator. Oh, it should be 180. I forgot my 1. Fix that real quick. Careful with that. And then, so 70 pi over 9, actually, is what it should be. Be careful with your calculator inputs. So that's A as in alpha. All right, so rewriting degrees, minutes, seconds in a decimal degree. And I think I've got another pending wrong account here. Trying to keep up with this. Goodness sakes, you guys, sign into your EHS accounts, please. All right, so 24 degrees, 38 minutes, 42 seconds. So remember that minutes are 1 over 60 and seconds are 1 over 60 squared. So 24 plus 38 over 60 plus 42 over 60 squared degrees. So we're going to convert that to a decimal, and it says to the nearest thousandth. So 24 plus 38 over 60 plus 42 over 60 squared is 24.645. And it is an exact thousandth, so that's F as in foxtrot. And as always, just call out if you are confused. If something doesn't make sense to you. Or you can type in chat, and it gives me a prompt, and I'll try to listen for that as well. All right, number 3. Tires are rotating at a rate of 18 RPMs. Find the angular speed of the tires in radians per minute. Well, remember that omega, which is the angular speed, is the angle in radians divided by time, the amount of time that passes. So this is 18 RPMs. So that's 18 whole circles, which in radians is 2 pi. So 18 times 2 pi, and that's in radians per minute. So that's going to be 18 times 2, or 36 pi radians per minute. And that looks like C is in Charlie. Now be careful on the actual test. Not necessarily this one, but definitely the next one. there's going to be some unit conversion that has to be done, so be careful with that. Just double check this and make sure nobody's pending trying to get in. Okay. So there are 20 rollers. This is number 4. There are 20 rollers under a conveyor belt, and each roller has a radius of 15 inches. So these rollers have a radius of 15 inches, and they're rolling that way. They turn at a rate of 40 RPMs. What is the linear speed of the conveyor belt? Notice that this is in feet per second, and this is in per minute. So if I want to know how many revolutions per second, I need to multiply that by 60 equals 40 times 60, 2,400 revolutions per second. So converting it to seconds so we don't have to do the conversion later. You could do it at the end, but it might be a little trickier. And remember that this also is in inches, and this is in feet. So we're going to have to convert that as well. But I'll wait till the end to do that. Okay, so 2,400 revolutions per second. And remember that the speed, or the velocity, is equal to the arc over time. And the arc is equal to r times theta over time. And the time is just going to be 1 second. So the 15 inches times the 2,400, use my calculator here. I meant to multiply by 1 over 60. I knew something was jacked up there. So it would be 1 over 60, not times 60. Fix that real quick before we get too much further. So 40 over 60, which is going to reduce to 2/3. That makes a lot more sense. So you've got 40 RPMs, but per second. So if it goes this many per minute, it's only going to go 2/3 of the revolution per second. To go from minutes to seconds, we multiply by 1 over 60, not 60 like I did earlier. That was stupid. So 40 over 60 reduces to 2/3. So 15 times 2/3 is r, the radius, times theta, the radians swept out, per second. And then, of course, that's going to be multiplied by 2 pi. So this is the revolutions times the radians in a circle. All right, so these can get kind of tricky. You got to keep a lot of things in mind simultaneously, but you can do it if you take your time. And you guys have an unlimited amount of time on the test. So, basically. All right, and that's again over just the time, which is 1 second. All right, 15 times 2/3 is 30 over 3, or 10 times 2 is 20 pi over t. And that's, think about our units here, that's in inches per second. So we want feet per second. We've got to multiply again times 1 over 12 to change those inches to feet. It takes 12 inches to make a foot. So for every inch here, I have to have 1/12 of a foot. Okay, so that's 20 pi over 12. And that's in finally feet per second. And let's reduce that. Let's just see if it comes out the same. I worked it out slightly differently before. That's what I was looking at there. So divided by 12. Yeah, it's the same answer. So 5.2 feet per second. So that corresponds to H is in hotel. Now notice the application of the formula wasn't a big deal at all here. The big problem was the unit conversion, which I'm not wild about that, but I think it is good practice for you. less to do with trigonometry and more to do with unit conversion in this case. So let tangent of theta equal 7 over 24. This is number 5 now. And we want to find where sine is positive, find the exact value of sine theta. Well, first of all, tangent theta equal to 7 over 24 is going to mean that we're either, because this is positive, we're in either Q1 or Q3. The tangent is only positive in Q1 or Q3. And then we're also told that the sine is positive, so that means we're in Q1. So we know it's going to be a positive sign. We don't have to worry about that. Know that just from this. So reference triangle time. We've got some angle theta where the ratio of the opposite to the adjacent is 7 to 24. Now we use the Pythagorean Theorem. Find that hypotenuse. So that's going to be 7 squared plus 24 squared. And then we're going to take the square root of that, which is 25. So the sine, in other words, the opposite over the hypotenuse, is going to be 7 over 25. A is in alpha. All right. As usual, just stop me if you have a question, thought, comment. I'll check the chat window real quick here. Make sure nobody has any comments. None so far. Okay. All right. 6. Find the exact value of cosine theta. So you're given a triangle here. You need the adjacent. So we need that side. We know it's 4 and then 8. So a squared plus 4 squared equals 8 squared by the Pythagorean Theorem. A squared equals 48. So I subtract 16. And a is the square root of 48, which is not fully reduced because that's radical 16 times radical 3, which is 4 on the square root of 3. So that's our a value. So adjacent to hypotenuse is going to be 4 on the square root of 3 over 8, which is going to reduce to radical 3 over 2. H as in hotel. That's number 6. Again, stop me if you get confused about something. Number 7, the arc length of a sector of a circular patio is 7.7 meters, and the central angle is 105. Find the diameter. That is super tricky. Once again, they're worried about units instead of the trig, which I don't love. But it's super tricky because what you're going to get from the formula is the radius. And then you got to figure out the diameter. So real easy to mess this one up, just like number 4. And they're going to be in a different order on your test. The answers are going to be in a different order. So, you know, it might not be the 4th one you come up on, but you'll have a corresponding problem. Okay, so 7. We need to, first of all, remember that S equals R theta. That's our arc length formula. And let's diagram this real quick. So we've got something like this. The central angle is just bigger than a right angle, 105. We're worried about this arc length. It is 7.7 meters of arc. And so we need to first convert this to radians because we can't plug in a degree into our arc length formula. The input must be in radians. So that's 105 times pi over 180. And if we reduce that, (7 pi over 12). So that's what we're going to plug in here. So S is 7.7. R, we don't know. That's what we want to know. Times 7 pi over 12. So if I have a fraction multiplied by my variable, I can multiply both sides by that reciprocal. And those will cancel, like so. Hey, buddy. So let's figure out what this is roughly equal to. It's going to be our radius, not our diameter. That's why this problem's so tricky. So 12 divided by 7 pi, and then times 7.7. That's the radius. Let me make sure, see where I messed up here, because that doesn't seem right. 12 over 7 pi. Ooh, yeah, I bet I know what happened. When I had this in, I should have put this in parentheses here. So 12 divided by 7 pi. Yeah, you got to put it in parentheses, right? See how it's different? All right, now that times 7.7. 4.2, that's what I'm looking for. Okay, so again, careful with calculator inputs. So 4.2, that is our radius, not our diameter. We have to double this. 8.4, and it's in meters. So C is in Charlie. All right. Number 8. Identify the coterminal angle to negative 120 that is on the positive or negative unit circle. So negative 120 is going to be something like that. Actually, I made it like 135. Kind of OCD. Let me fix that. All right, that's a little closer to accurate. Negative 120 degrees will look like that. So what's the positive coterminal angle? Well, that would be this. So that's 180, and then 60 more, 240 degrees. So positive 240. H is in hotel. You don't want to miss that one. That one's a gimme. Number 9, a circular pizza box logo has a sector. Remember, that's like a slice of pizza with a central angle of 80 degrees and a diameter of 16 inches. So the diameter is 16, and there's a sector with a central angle of 80 degrees. Find the area of the sector. Okay, so first of all, we have to remember that the area equals 1/2 r squared theta, where theta is once again only in radians, not in degrees. Here we've got it in degrees, we'll have to convert. But I do know the radius, which is half the diameter. And then we have to figure out the angle in radians. So 80 times pi over 180, and man, they get excited out there. And that's going to be, we'll use the calculator to reduce it real quick. 80 divided by 180, math, enter, 4 pi over 9. So we'll use the calculator to approximate here. So 0.5 times 8 squared times 4 times pi divided by 9. And so that's about 44.68, which rounds up to 44.7, and that's the answers they're looking for. A is in alpha. Just make sure I've got no comments or anything. Okay, cool. Number 10. Let -2, -4 be a point on the terminal side of an angle. So we've got this angle, theta. Find the exact value of the secant of theta. So 10, we'll remember that the secant of theta is the inverse of the cosine, because the cosine is x over r. So this is r over x. We need to find r. So that's going to be the square root of x squared plus y squared. So that's the square root of 4 plus 16, which is the square root of 20. which is the square root of 4 times the square root of 5, factoring out the perfect square factor to get 2 on the square root of 5. So now I'm going to say 2 on the square root of 5 over negative 2 is going to be negative radical 5. J as in Juliet is the answer we're looking for there. Okay, so this is about the halfway point. So if anybody has any questions about anything, let me know. Okay, cool. All right, number 11. So write an equation of the tangent function with period 3 pi over 8. Let's start with that, because we know the period for the tangent is going to be that original period divided by the absolute value of b. So pi divided by b, we'll just consider b positive. If you look at the answers here, all the b's are positive. You don't have to worry about a negative b. Is 3 pi over 8. So what I can do is, to solve this, is cross multiply. So I've got 3 pi b equals 8 pi. Divide pi from each side. 3b equals 8. Divide by 3. And b equals 8/3. So we know that b is going to be 8/3. That means we can disqualify this answer based on that first bit of information. Using those formulas I taught you about the period, the amplitude, and so on and so forth. Next it says phase shift negative pi over 5. Well, remember that the phase is going to be negative c over the absolute value of b. We already know b is 8/3. So that means negative pi over 5 is going to equal negative c over 8/3. So if I multiply both sides by 8/3, and then I multiply both sides by -1, 8 pi over 15 equals c. So that disqualifies this answer. So we know it's either A or C at this point. So we analyze the phase information, period information, and now we say vertical shift -2. Oh, I see. See, it's positive here and negative here on A. So therefore, it has to be the positive one. So it's C is in Charlie. Yeah, we already would have known that. The -2 doesn't narrow it down any further, but because our C value is positive, only the positive one here. They got kind of tricky with that. Gave us a really good distractor answer with A. But because this is also positive, that's why C is the correct answer. Okay, number 12, architecture. So the angle of elevation from the tip of a building's shadow to the top of the building is 63 degrees. That's this angle. And the distance is 220 feet to the top from that point. Find the height of the building to the nearest foot. So we want to know X. We're talking about the opposite side and the hypotenuse. So the sine is what we need here. So that's going to equal the opposite over the hypotenuse. So if I multiply both sides by 220, get this. And if I approximate that to the nearest foot, it looks like 220 times sine. What mode am I in? I'm in degrees. Okay, so I'm good. Sine of 63. 196 is the nearest foot. J is in Juliet. All right. So these last 8 or so are much harder. Not all of them, but most of them are much harder. So be prepared to spend the bulk of the test time on especially the last few. Okay, so assuming the angle's in quadrant 1, find the exact value of the tangent of the cosine inverse of 4/5. So remember, this is just some angle alpha. Cosine inverse takes a ratio and maps it back to an angle alpha. And what do we know about that angle alpha? Well, we know it's in quadrant 1, so everything's positive. We don't have to worry about negative values. We also know its cosine ratio, in other words, adjacent to hypotenuse is 4/5. And because of that, I also know this is 3. Remember the Pythagorean triple, 3, 4, 5. I don't even need to work that one out to know that's a 3. So the tangent of alpha is going to be the opposite over the adjacent, which is 3/4. A is in alpha in this case. All right. Checking for questions again here. Looks like none. Okay. Number 14. State the period of the following, and then it gives us a function. Remember, the period is impacted by the b parameter, which is in this case 4. So the period is going to be 2 pi, because it's a sine function. Sine function has a default period of 2 pi, divided by the absolute value of b, and so that's going to be pi/2. H is in hotel. Make sure and ask me a question if you get it. I'll try to keep checking that. Then number 15, find arc sine, which is another way to say the sine inverse. So this question says, these are the ones I like to work out because they really exercise your knowledge of the unit circle. So at 60 degrees, the y value is the square root of 3/2. So this is going to be 60 degrees. You could also do it in your calculator like so. So I'm in degree mode, so that's where I need to be. Not in degree mode. When you need to be, you're going to get a weird answer. And if you're in degree mode when you try to graph, your graph's going to look weird. All right, so that's 15. Let's talk about 16. The side view of a skateboard ramp is a triangle with the following. So we're going to A, we're going to B, we're going to C. Absolutely not the scale here. 41 degrees, 107 degrees, and then C is 19. This is a law of sines problem. And you might say, wait a minute, we don't have an angle in its opposite side. No, but we can get it pretty easy because finding angle C is trivial in this case. 180 minus 107 minus 41 is 32 degrees. So the sine of 32 degrees over 19 equals the sine of 41 degrees over the unknown side A. So that's going to give us A. And we don't want A, we want B, so let's do the other. You don't even have to solve the whole triangle in this case. You just want one of those values, so we'll just find that one. So B is going to be found by taking the sine of 107 degrees over B. Cross multiply and so on. 19 times sine of 107 equals sine 32 degrees times B. Divide both sides by the sine of 32 and you get B equals this expression. And we'll punch that in our calculator to get an approximate value for B. 19 times sine of 107 and then divided by the sine of 32. 34.3 to the nearest tenth, which is what the answers are in. So that's J as in Juliet. Again, we're talking about 16. 17. Which of the following is a vertical asymptote for the graph of y equals secant x plus 3? So this plus 3 is kind of a red herring. It's just going to shift the graph up 3 units. It's not going to modify our input, which is not going to modify our vertical asymptote. So it's going to be the same as the regular secant. And remember, the secant is equal to 1 over the cosine. And so cosine of x can't be equal to 0. And remember, that happens where you have pi over 2 plus n pi, where n is an integer. So we're looking for pi over 2 plus n pi, and there it is. A is in alpha. It's going to be a vertical asymptote for the secant. Okay. Any questions about anything so far? Thoughts or comments? All right, you guys are particularly quiet today, but I see that you're there, so I suppose that's good. Just double checking everything. Okay. 18 is in triangle DEF. Again, not to scale. We've got E is 52 degrees, D is 14, and F is 9. So find E. So the only way to find E in this case is to use the law of cosines, because I do not have an angle and its opposite side, and there's no way I can get it without using the law of cosines. So I need to use this flavor of the law of cosines. And in case you didn't notice, whatever variable you pick here, that's the angle that winds up here. And there's a pattern for the other two sides. So hopefully you guys can see that. So if we plug things in here, we get our unknown side E is equal to 9 squared plus 14 squared minus 2 times 9 times 14 times the cosine of angle E, which is 52 degrees. I'll go ahead and plug that in. And so E squared, if I estimate this with my calculator, there's no variables on the right side there. I can just plug that whole string in. Times cosine 52. So that's 121.9. And so E is about, take the square root of this, 11 units. So that's G is in golf. Yep. So law of cosines can be tricky to set up. This first bit right here, that would, just that step, probably a good 20% of people would get wrong, maybe even more. So this is where you've got to really put your mental energy into setting the problem upright. Once you do that, it's trivial. All right, 19. Mrs. Lindsay designated a triangular area in the auditorium for art projects. The dimensions of the triangle are as follows. So we got 32 feet, 26 feet, and 40 feet. Not to scale. What is the area of this triangle? So we're going to use Heron's formula, and we're going to take the semi-perimeter. Remember, that's important. So we add up everything and then divide by 2 to get the semi-perimeter. So 32 plus 40 plus 26 is 98, divided by 2 is 49. So the semi-perimeter in this case is 49. And remember, the formula is the area is the square root of that semi-perimeter multiplied by the difference of that semi-perimeter in each of the three sides. So that's going to look like this. Okay, so we'll approximate this with a calculator. 49 times 49 minus 32 times 49 minus 26 times 49 minus 40, about 415.2. That's going to be in whatever units we got going on squared, so feet squared. 415.2, that's D as in delta. Okay, one left, gang. So in triangle RST, R is 7.8. S is 4.2. And T is 3.9. Find the angle R. So this is the angle we want to figure out. We're going to do that using, once again, that good old law of cosines. So we're going to use this one. R squared equals, and then it's going to be S squared plus T squared minus 2ST cosine R. So we know everything but the angle for this. So this is 7.8 squared equals 4.2 squared plus 3.9 squared minus 2 times 4.2 times 3.9 times cosine R. This is really easy to make a calculator error or a simplification error once you get it into this format, so be really meticulous. I'm going to subtract away 4.2 squared and 3.9 squared from each side to get the following. And then once I'm here, I'm going to divide away this bit from both sides, of course. Now, you could probably skip that step if you're really adept at algebra, but I caution you not to on a test problem. Just give yourself every opportunity to get it right. So if the cosine of R is this value, the R is going to be, you guessed it, the cosine inverse of this big old mess right here. So let's approximate that. Remember, the cosine inverse will tell on you if you have your parentheses wrong. Usually, it's going to say domain error, because the domain is just so tightly constrained. If you put something in there wrong, it's a very strong possibility. Like I just did, I forgot the square there. Okay. It's very likely to throw an error. That's a good thing. That helps you get the problem right. You're not going to go ahead with an answer after the calculator's told you it's wrong. All right, times 3.9 should be it. So it says 148.7 degrees. Shows just how out of scale our model was here. So that's J as in Juliet. All right, and that, ladies and gentlemen, is the super scary Chapter 4 practice test. If you've got any questions about anything, go ahead and let me know, and we'll discuss them really quickly. Oh, goodness. Let's see. All right, does not look like that's the case. Give you guys just another minute to think of one. Sounds like somebody had a question, so. Let's see what they got. Could you do homework problem 35 on page 277? Let's take a look at that one. 35, page 277. Yeah, photography. Okay, so make sure you guys can still see that, hear that. 35 on page 277. So this says, dude's taking pictures of a hawk that's flying over top of him. The hawk will eventually fly directly over him. Let D be the distance he is from the hawk, theta be the angle of elevation. So write D as a function of theta is our first task. Number 35 on page 277. So if we look at this triangle, we see that we're talking about the opposite and the hypotenuse. So we're going to use the sine. So the sine of theta is going to be equal to 150 over D. But we want to solve that for D. So it says write D as a function of theta. So if I multiply both sides by D, we get this. And then if I divide away the sine theta, I get this result. So the answer is D is 150 over sine theta. That's the A part. The B part says graph the function from 0 to pi, which we'll just use our handy dandy calculator for that. So we want 150 divided by sine theta. We'll use X, of course. So we want to go from, it says 0 to pi. So 0 for the X min, pi for the X max. And we'll go just -1 or something to 150 is the max distance, I believe. Let's graph and see what that looks like. And we might need a little more Y. Also, oh, look at that. I was in degree mode. So no wonder it looked weird. Yeah, still need a little more Y. So let's go 300 maybe. There we go. So it flies right over top of him. So you're going to, if I traced along here, what's going on with this is so as the theta approaches directly over his head, it gets closer, and then after the bird goes over his head, it's further and further away again. So that's why that looks like that. So the sketch should look something like this. And then approximately how far away is the hawk from Jeff when the angle of elevation is 45 degrees? Now we graphed it in radians here. So if we're going to trace, we need to put 45 degrees in as a radian. So that's pi divided by 4. And it's about 212.1 feet. So B is the graph I just showed you. And then C is 212.1 feet. All right, that's a good question, Clay. Anybody else have a question, a thought, or a comment? We've got several minutes left here if we need them. Luke Shepard, if we do not have any more questions, are we allowed to go ahead and go? Yeah, but shouldn't be your primary concern, sir. All right, in that case, I'll call the meeting to a close, and I'll post this video, and I'll post the notes and all that on a study guide, and I'm also going to open up the test. So good luck, you guys. Hope you do well, and hope you have a good day.